Number 1, measure of angle RTU equals 13x minus 2. Measure of angle STR equals 6x plus 3. And the measure of angle STU equals 153. Find x. So, RTU is 13x minus 2. STR, 6x plus 3. And the whole thing is 153. So solve for x, we're going to have to add angle RTU plus angle STR to get angle STU equal to 153. So 13x minus 2 plus 6x plus 3 equals 153. That's just an algebra problem from here. So combine our like terms, 13x plus 6x, 19x, negative 2 plus 3, plus 1, plus 153. And subtract 1 from both sides. 19x equals 152. And then divide by 19. Which is going to be 8, I believe. All right, number 2, measure of angle GMN equals 5x plus 9. Measure of angle LMG equals 120 degrees, and the measure of angle LMN equals 29x plus 9. Find x. So GMN, 5x plus 9. LMG, 120. And LMN, the whole thing there, is 29x plus 9. So those two smaller angles have to be added together to equal the biggest angle. So 5x plus 9 plus 120 equals 29x plus 9. So 5x plus 129 equals 29x plus 9. So subtract 5x from both sides and subtract 9 from both sides. So 120 equals 24x. So divide by 24. All right, x equals 5. All right, number 3, measure of angle GHI equals 148. So the whole thing is 148. RHI is 120. And find the measure of angle GHR. This is actually the easiest one of all of them, because we call GHR x. We have x plus 120 equals 148. Subtract the 120. X is 28. Alright, numbers 4 through 9 are all about parallel lines and the angle relationships that we have with parallel lines or with just intersecting lines. Like number 4, we got two parallel lines. They've given us these two angles, which these are not based on parallel line relationships because both angles, or both of these items that we're dealing with, are at the same intersection. We don't have one at this intersection and one up here at this one. But what kind of angles are these? These are vertical angles, straight across from each other at the intersection. And so vertical angles are congruent. So to solve for x here, we've got to set these two equations, or these two angles, equal to each other. So 11 plus 2x is going to equal 13x plus 4. So subtract 2x and then subtract 4. Oh, that's a 12. Thank you. All right, so subtract 12x. and subtract the 4. 4's cancel, and we have 7 equals x. Number 5, at the parallel lines, we know they're parallel because they got the little extra arrowheads on them saying that they're parallel. And we got 2 angles that are in between the lines on different sides of the transversal, also known as alternate interior angles. And the rule is that if the lines are parallel, then the alternate interior angles are congruent. So to solve for x, we set these 2 angles equal to each other. Those 2 angles should be the same measure. So 20x equals 6 plus 19x. Subtract the 19x. X equals 6. All right, number 6, once again, different sides of the transversal, in between the 2 lines, alternate interior angles again, so they should be congruent, should be the same, so we set them equal to each other. 4x plus 16 equals 5x plus 5. So subtract 4x and subtract 5. So 11 equals x. Number 7, we're outside the 2 lines, but on different sides of the transversal. So these are called alternate exterior angles. And alternate exterior angles are congruent if the 2 lines are parallel. So once again, set them equal. 36x minus 4 equals 34x plus 4. So subtract 34x and add the 4 to both sides. So 2x equals 8. Divide by 2. X equals 4. Number 8, the one oddball here. We got same side of the transversal in between the 2 lines, known as consecutive interior angles, or same side interior angles, either way. And so they're on the same side in between the 2 lines. The rule is that those are supplementary. Otherwise, they end up adding up to 180. So 2 angles added together should equal 180. 100 plus x plus 87 equals 180. Combine our like terms, 187 plus x equals 180. Subtract the 187. So x equals -7. And number 9, parallel lines again, but these are not on the 2 different intersections. They are straight across from each other at the intersection. So once again, we've got vertical angles, and vertical angles are congruent. Doesn't matter if lines are parallel or not because they're not on 2 different intersections. They're at the same intersection. So set them equal. X plus 137 equals 130. Subtract 137. And x equals -7. All right. On to the next page. Find the value of x that makes lines U and V parallel. So we're using the same rules, just kind of in reverse. If it's in reverse, then that'll tell us, based on the rule, the lines will be parallel. So 8x minus 1 and 6 plus 7x are corresponding angles, which go from here. Actually, y'all don't have these on your review.
Yeah.
Just realized that I made this off of the unchanged review that I didn't give y'all, but still follows the same ideas here. So number 10 is kind of like number 11 on the review. So 8x minus 1, 6 plus 7x, corresponding angles. For the lines to be parallel, the corresponding angles have to be congruent. And so 8x minus 1 equals 6 plus 7x. So subtract the 7x. So x minus 1 equals 6. Add the 1. X equals 7. Now, so I'm just going to do $11 like what was actually on your paper. 11 is 115 and 16x plus 3, which would be corresponding angles, just like that last one. So you'd set them equal. 16x plus 3 equals 115. Subtract 3. 16x equals 112. And divide by 16. And that would be x equals 7. And I'll go ahead and do 12 like your 10 was set up. So just so it matches. So 10 was 120 here and 7x minus 3 there. And so those are consecutive interiors. So consecutive interiors have to be supplementary if the lines are parallel. So added together, 120 plus 7x minus 3 should equal 180. So combine the like terms, we have 117 plus 7x equals 180. Subtract the 117. 7x equals 63. Divide by 7. X equals 9. All right, let's skip number 13 here. I think everything else matches up. Just that section changed when I modified it before I gave it to y'all. Just somehow the modification didn't stick here. All right, so this is actually 12, 13, 14, and 15. All right, number 12 through 15, name the relationship: complementary, linear pair, vertical, or adjacent. So when we look at these two, they are side by side, which would make them adjacent. But we're going to go with the most relevant description. So adjacent is side by side, but since these are side by side and the two angles make a straight line, they're a little more than just adjacent. They are a linear pair. Number 13, basically almost the exact same setup as 12, side by side, making a straight line. So once again, 13 is a linear pair. 14, side by side, making a straight line. Linear pair. And then 15, they're side by side. They don't make a straight line though, so they don't fit linear pair. They would be adjacent, but we also notice that we've got a right angle over here, so that means that that side has to be a right angle as well. So the most relevant description of these being adjacent and making a right angle would be that they are complementary. So in order to say adjacent, they would need to not make a straight line and not make a right angle, just be side by side. And this didn't include vertical angles in this group. I'm using a test generator that automatically pulls these up. So if A had not been there, it had been there on 14, then those are straight across from each other at the intersection. Those would be vertical angles. Right? Just a little reminder for the test. All right, so 18, 19, find the measure of angle B. So we got two angles side by side making a straight line. So in this case, those are a linear pair, and the rule for a linear pair is that the angles of a linear pair are supplementary, because the measure of a straight line is 180 degrees. So supplementary means they add up to 180. So to solve for B, we're going to say 70 plus the B has to equal 180. Subtract 70 from both sides, and B equals 110. 19. You got two angles straight across from each other at an intersection. Right? Or really the technical definition says two angles such that their sides form two straight lines. And so this side makes a straight line with the other side of 33, and this side of the 33-degree angle makes a straight line with the other side of B. So those two should be congruent, which makes this really easy. There's no calculation needed, just B equals 33 degrees. All right, so on to next page, which this is actually, let's see, 18, 19, 20, 21, making the numbers match yours. So find the value of X. All right, so we look here, we have a right angle marked here, red box. So that means that the other side of that intersection should be a right angle as well. And so to solve for X, we know that these two angles combined should equal 180. So X plus 12 plus 63 should equal 180. So X plus 75 equals 180. Subtract 75. X is going to equal 105. That's all we're doing is solving for the X. All right, 19. We got X minus 23 and 94. They show us that this angle going around the backside is 241 degrees, which is part of a circle. And a circle is 360 degrees all the way around. So start off with, we can do 360 minus 241, which will be 119. So this side of those angles has to be 119 degrees. So X minus 23 plus the 94 should be 119. So combine our like terms on the left side. Negative 23 plus 94 will be plus 71. 119. Subtract 71 from both sides. And X equals 48. My math is right. So find the measure of each angle indicated. All right, so we got triangles. We know that all three angles in a triangle have to add up to 180 degrees. So this is just simply subtracting from 180, basically, the two angles that we know. So, or saying 95 plus 45 plus x, the angle we don't know, has to equal 180. So 140 plus x equals 180. Subtract 140 from both sides, and x would be 40. So that angle there is 40. Add them all up, that should equal 180. All right, 21 there, same idea. Three angles should add up to equal 180. So 40 plus 60 plus the angle we don't know equals 180. So that's 100 plus x equals 180. Subtract 100. So the missing angle must be 80 degrees. All right. 22, 23, still following the same idea. Triangles, they've got to add up to 180. Of course, in 22, you got a right angle here. So we know that's 90 degrees, which means the other two angles of a right angle, of a right triangle, have to be equal to 90. So we can leave this 90-degree angle out and just set these two equal to 90. Or you could add them all up, including the 90, to set them equal to 180. But x plus 62 plus 40 is going to equal 90. If you included the 90-degree angle, you would set it equal to 180. So x plus 102 equals 90. Subtract 102. X equals negative 12. 23. Three angles have to add up to 180. So 64 plus 79 plus x plus 49 equals 180. And so add up our angles there. 191 or 192 plus x equals 180. Subtract 192. X equals negative 12. Make sure my math in my head is correct. 64 plus 79 plus 49. Yeah, 192. All right, we're good. So then 24, 25, and 26. Classify each triangle by its angles and sides. So we're just looking at the angles and the sides, coming up with a name for each version. So by the angles, you got 60, 60, 60. All three angles are the exact same. So that's equiangular. And then if we look at the sides, 18.1, 18.1, 18.1, all three sides are exactly the same. So that is equilateral. So equiangular, equilateral. All the sides are the same, all the angles are the same. 25 by the angles, 61, 78, 41. All of those angles, if we look at them, are acute angles. They're all less than 90. So that makes it an acute triangle. And then by the sides, 2, 3, 20, 2, 3, and 2.7. So all of the sides are different lengths. So the name for that is scalene. So an acute scalene triangle. 26. We've got by the angles, 20, 20, 140. So we got two acute angles, one obtuse angle. So the one obtuse angle is what names the triangle. So it takes one obtuse angle to make it an obtuse triangle. And then we look at the sides, 2.3, 2.3, 4.3. So we've got two sides that are the same. And two congruent sides is known as isosceles. Then 27, 28, 29, 30, and 31 are determining if the triangles are congruent, and if they are, we'll state how we know, which we're just going to give the postulate or theorem that would determine that they are. So we got two sides that are marked congruent, and all right, so we got two sides congruent, the angle in between them, so that would be a yes, they are congruent. And how we know, we've got a side, an angle, and a side that are congruent. Two sides, the angle in between them, side, angle, side. All right, so 28, we got one angle, two angles congruent, and then the side that is trapped in between those, called the included side, is congruent. So that is also enough to prove them congruent. And by an angle, a side, and an angle. Angle, side, angle. ASA. 29. We've got two sides, but not an included angle. And we don't have an angle side, side. But since we've got a right angle right here, and that would be a vertical angle with this angle right here, those are both going to be right angles. And when we've got right triangles, then it only takes two sides as long as one of them is the hypotenuse. So you've got hypotenuse and a leg. And so with a right triangle, you can say, yes, that is congruent by HL, hypotenuse leg theorem. All right. Number 30, you got two sides and an angle. So you got an angle and a side, angle and a side. Since they intersect right here, that's a set of vertical angles. So we know that vertical angles are going to be congruent. And so now we've got two angles with the side in between, two angles with the side in between. So that would be a yes by angle, side, angle. See if I can get this one more done before the bell rings. Here. So once again, we got an angle marked congruent and a side, an intersection. So the intersecting angles, the vertical angles there would be congruent. So we got an angle, a side, an angle, angle, and a side. So this one is also a yes by angle, angle, side. All right, so I will pick up from here on part 2 of this recording. So if you want to watch the rest of it, find part 2. Thanks.